Well, we just simplified two rational expressions. Now what I want to do is move to the other side of this section, and we want to actually solve some rational equations. Let's get a different color here. Alrighty, so the big difference between simplifying versus solving. Simplifying, you want to get a common denominator and put your fractions together as one. Solving, we want to think about what the common denominator would be, but actually by doing that, we want to eliminate it so we can solve for x. So there are two different problems you're doing. They both involve fractions. One involves just getting the fractions together. The other is technically trying to get rid of them. So what we decided to do on these was find the LCD, the least common denominator of all three fractions. So if you look at all three denominators, let's just first start with a number. What's the lowest number that 3 and 6 and technically a 1 would all divide into? It would be 6, right? So that's your least common denominator as far as the coefficient goes. Now, two of these fractions have an x. One of them does not. In order for them to all match, they would all three need an x. So your LCD is going to be 6x over 1. And what we decided to do was multiply every single term by the LCD over 1. Every single term. So this is where we wrote all of this out. And it's going to make it look complicated, but it is going to actually all work out to be pretty nice here in a second. Okay, so what I want you to do when you do that is I want you to section off those little parts where you have two fractions that are multiplied together, right? This separates your area into 3 workspaces. You know, in each one of these boxes, you've got to clean it up. You got to figure out what's left over after I multiply these two fractions together. So this is actually a little bit of a simplified question, okay? So in these two boxes right here, what can we cancel on the top and the bottom that's the same? X's are gone. X's are gone. All right, now, you could think about, how do I simplify maybe some of these factors? But if you don't see that, that's fine. What you can do is you can just go ahead and multiply together what you have left over, and then we can reduce it from there. All right, so if you multiply straight across like you do with fractions, that would be 12 over 1 times 3 is 3. And what's that going to be? A 4. Okay, so if you don't see it there, you'll probably see it when you write it as one fraction. All right, plus let's see what happens over here. X's again. Nope, X's are not going. This time the 6 is canceling with this 6. All right, so the X's are not canceling on this. You have X times 5 left over. So I would say that is 5X. So let's bring it down. Equals, now what's going on over here? Okay, now this X and this X will not cancel, right? Because this one's part of an expression. But this X is able to cancel with this one because these are connected by multiplication. All right, and here's where you got to be careful because look, you have X minus 2 times 6. So it's not just one of those terms that gets multiplied by 6. It is both of them. So let's write this as 6 times, in parentheses, X minus 2. And yes, you do need to distribute that. So that would be 6x minus 12. All right, so look what we've got now. A basic equation you probably would have seen in Algebra 1 pre-algebra. We want to clean this thing up. We got to get x's on one side, numbers on the other. I vote let's take this 5x over, and to undo that, we need to subtract it on both sides. So that becomes a positive x on the right. And then we still have this 4 left over. Alrighty, now to get x by itself, we need to add 12. And that makes us end up with a 16. So there's your answer on that one. All right, LCD over 1 multiplied by each term. Let's do another one. Alrighty, so one thing I've noticed is when you have a question like this where some of it is shared on fractions, y'all tend to overestimate what you need. So let's just think about the LCD, the least common denominator. What is the least amount we need on every single fraction in order for them all to match? Well, this fraction has a 3 on it. So that tells me right now, if these are 1s, that I do need a 3. Okay. And I can get that easily by doing 1 times 3. All right, now this one has x squared. This one has x squared, right? There's the bar has been set. So what does this term need? It also needs 1 more x on it, but that would make it have x squared, right? So the LCD is 3x squared. I need a 3 and an x squared on all 3 fractions for them to match. So that's what we're going to multiply every term by. So here we go. And I know that this step requires some writing and it takes some time, but I think if you've been doing it, you understand why it is important. It really does save you some errors and it makes it easier. Kind of helps you see where things are going and why they're going away. All right, so in this first box, well, 3x squared and 3x squared cancel. We're left with 1s. So what's 1 divided by 1? 1. Every time you have 2 fractions and they completely cancel each other out, you have to have something in its place. It has to be a 1. All right, on this one, I say that this x would cancel with one of these. So if that's an x squared, now it's just a plain old x. So you could cancel these ones if you want to. You don't have to, but that kind of does visually let you see that 3 and x are the only 2 things left in there. All right, that was from that box. Minus. Okay, now we could have done a plus a negative 2. I guess I can do that now. All it's going to do is just change it like this. There we go. All right, so what's happening in here? Well, x squared and x squared are gone. Now, notice what happened on every single one of these sections where I blocked it off. Every single time, the denominator was gone because you are making this to where your LCD will ensure that everything on the denominator is canceling with the LCD. Something in there is canceling with it to make it go away every time. And if it's not, then we've got a mistake somewhere. All right, so here we've got a negative 2 left over and a 3. Negative 2 times 3 would be negative 6. So that's what we're dealing with over there. We just got to get x by itself. Let's add 6 to make that a 7. And then we just got a plain old 3x over here. Divide by the 3. And we end up with a fractional answer on this one. That's okay. It doesn't always have to be something nice and pretty. Fraction is an okay answer.